Okay, 8th graders, we are moving on to section 1.3, properties of numbers. So this table is very helpful. We talk about 5 different properties here. The commutative property tells us that when we're adding or multiplying, we can change the order of things. 6 plus 8 is the same thing as 8 plus 6. Okay, the commutative property. Then we have the associative property. The associative property tells us that when we're using addition and when we're using multiplication, this works, just like the commutative. It only works with those two. It tells us that we can change the order that we're doing something. So for example, I can take 7 plus 9 first, and I get 16 plus 1, and that gives me the same answer as if I took 9 plus 1 first, and then I added 7 to get 17. Sometimes they're just easier because I would rather add 9 and 1 and get 10 than do 7 and 9 and get, 16. So sometimes we can make the problem easier for ourselves. The distributive property talks about how you can take something outside the parentheses and you can do that operation, so multiplication, so 6 times 9, and then you can add it to 6 times 3, and you'll get the same answer either way. The distributive property is one of the most common properties that you guys will continue to use. The identity property is when you add 0 or multiply by 1. When you do that, the number stays the same, so it keeps its identity. That's how I remember it. And then zero property is when you multiply by 0, it goes to 0. Okay. So just be careful because some people say, oh, I added 0, so that's a 0 property. Nope, it kept its identity, so that means it's the identity property. So I just have a few examples here. It says use properties to determine whether the expressions are equivalent. Remember, equivalent means equal. So for example here, if I have 3 times y times 5, is it the same thing as 15y? Well, it is, because the commutative property tells us that I can move things around, okay, and then I can do this first, so 3 times 5 is 15 times y, and that equals 15y. So it says use properties to determine, so I use the commutative property, and yes, they are equal. Okay, so my next one. This one, I have parentheses, which a lot of times people put with the associative property, but I can't do what's inside the parentheses, so I am going to distribute. So 4 times x plus 4 times 7. And we are seeing if these turn out to be equal to each other. 4 times x is 4x. 4 times 7 is 28. Now, are these equal? No. And then y, we use the distributive property. Distributive property shows they are not. Okay. Sasha's list of favorite movies include 12 action films, 19 comedies, 8 science fiction films. Use properties and mental math to answer each question. Oh, maybe we forgot some questions. So the one thing, let's just think about this. How many movies are there total? Okay, well, when I look at this, even though it says 12 plus 19 plus 8, I like to group them. So I would rather do 12 plus 8 plus 19. Well, why is that? 12 plus 8 is what? 20. 20 plus 19, I can do that in my head, is 39. So sometimes grouping nicer numbers together is helpful. Okay, so if Sasha wanted to download her favorite movies and it costs $8 to download a movie, how much would she need to save to download all of the movies on her list? So I've got 39 movies. And this is where we use the distributive property to kind of do some mental math. So one thing that makes things a little bit easier is that I know that 39 is actually composed of 40 minus 1. Would you agree with that? Okay. So if I do this, 8 times 40, 8 times 4 is 32, then add a 0, minus, what's 8 times 1? Is 8. So real quick, without any calculator, without any longhand math, I figured out that this was 312. Okay, it's a little way to use a distributive property because they say that you can split this up. This would be 8 times 40 minus 8 times 1. So it would cost $312. Okay, so we have to use counterexamples to prove these right or wrong. So the associative property is true for division. Can you use the associative property in division? Can you change the order of things? So let's try it. So, or not change the order of things, but change the order of how you do things. So 8, let's just do something simple. Let's do a bigger number. 20 divided by, oh, I've got to think of a nicer, I want nicer numbers. Let's do this one. 32, sorry, divided by 8 divided by 2. Okay, so order of operations tells us we're going to do this left to right. So 32 divided by 8 is 4, divided by 2 is 2. Okay, so now the associative property tells us that we can change where we put the parentheses. So for example, I'm going to put parentheses here on this one because that's the order I did things. Now I'm going to do the same order. I'm just going to put parentheses in a different spot. So 32 divided by 8 divided by 2. So in this one, I'm going to put parentheses here. So that means I'm going to do that first. What's 32 divided by 4? I get 8. Are these equal? No. So this is my counterexample. So you have to see if you can prove it wrong or right. The product of two whole numbers is always greater than either number. Okay, so two whole numbers. So for example, I could take 2 plus 3, and I get 5. Well, 5 is greater than 2, and 5 is greater than 3. What other whole numbers, though, can we look at? Well, what about if I just took 2 plus 0? 0 is a whole number, and is it greater than 2? No, because 2 is not greater than 2. So this is our counterexample that proves it wrong. Okay, so I know these are kind of tricky, some of this wording we have to try to remember from last year. We will do some practice of this in class.